Black screen, silence. Then a faint hum. A distant glow begins to rise on the horizon, not the gentle gold of sunrise, but something deeper, something wrong. The sky burns crimson. The sun is bigger, much bigger. And in that moment, before anyone can even understand what they're seeing, the fate of Earth is already sealed. What if the sun turned into a red giant tomorrow? Not millions or billions of years from now, but overnight. No warning. No gradual change. Just one ordinary day, followed by a sky that no longer belongs to us. To understand what would happen, we need to understand what a red giant actually is. Because this is not just a brighter sun. This is a completely different star. A star at the end of its life. Unstable, expanding, dying. And if that transformation happened instantly, Earth wouldn't just be in danger, it would be erased. Right now, the sun is stable. A main sequence star. At its core, hydrogen atoms fuse into helium. This fusion releases energy, light, heat, life. It's a delicate balance. Gravity pulls inward, fusion pushes outward. For billions of years, that balance has held. But one day in the far future, the sun will run out of hydrogen in its core. And when that happens, everything changes. The core collapses, temperatures rise, fusion shifts outward into a shell, and the outer layers begin to expand. Slowly at first, then dramatically, the sun will swell into a red giant, hundreds of times larger than it is today. Its surface will cool slightly, giving it that deep reddish color, but its total energy output will increase. It will become brighter, hotter, more violent, and its outer edge could stretch all the way to where Earth orbits today. But in reality, this process takes millions of years. It is slow, gradual, predictable. Our scenario ignores all of that. Tomorrow it just happens. No warning, no time to adapt. One moment the sun is normal. The next, it has expanded massively, its brightness has surged, its gravity has subtly changed. And Earth is suddenly sitting inside a completely different cosmic environment. Let's begin at the moment of transformation. The first sign would be visual. The sun would appear enormous in the sky, not slightly bigger, but impossibly large. It would dominate the horizon, a burning red disk swallowing the blue of the sky. Daylight would become intense, not warm, not bright, but blinding. Within minutes, the increase in solar radiation would begin to affect Earth. The atmosphere would absorb enormous amounts of energy. Temperatures would start rising. Fast. Within hours, the planet begins to overheat. The average global temperature would climb rapidly. 20 degrees C, 40 degrees C, 60 degrees C. This isn't a heat wave, this is planetary fever. Ice caps begin melting almost instantly. Glaciers collapse. The oceans absorb heat and begin to expand. Weather systems go wild. Hurricanes intensify beyond anything ever recorded. Winds reach unimaginable speeds. The atmosphere becomes unstable, and this is just the beginning. By the end of the first day, the oceans are no longer stable. Surface temperatures rise toward boiling point. Water begins to evaporate at massive scale. Steam fills the atmosphere. Clouds thicken, but they don't cool the planet. They trap heat, creating a runaway greenhouse effect. Like Venus, but faster, much faster, the air becomes heavy, thick, unbreathable, and across the planet ecosystems collapse. Plants cannot survive the heat. Photosynthesis stops. Oxygen production declines. Animals begin to die. Human civilization struggles to function. Power grids fail. Infrastructure breaks. Communication collapses because the environment itself is becoming hostile to life. Within days, the situation becomes irreversible. The oceans are boiling, not metaphorically, literally. Vast amounts of water turn into vapor. The atmosphere thickens with steam, but the heat keeps rising. Eventually, the upper atmosphere begins to break apart. Solar radiation strips molecules away. Hydrogen escapes into space. Oxygen reacts with surface materials. Earth begins to lose its water permanently. The sky, once blue, turns into a hazy orange. Then darker, then almost black. But the heat is only part of the story. The sun itself is expanding. In a true red giant phase, its outer layers can reach or even surpass Earth's orbit. In our scenario, that expansion happens instantly, which means Earth could find itself inside the sun's outer atmosphere. Not inside the core, but within a vast envelope of superheated plasma. At that point, there is no atmosphere, no oceans, no surface conditions that resemble a planet. Earth becomes a charred, molten remnant. Its surface melts. Rocks liquefy, metals soften. The planet glows. There's more. As the sun expands, it loses mass through stellar winds. This changes its gravitational pull. Earth's orbit could shift. It might drift outward slightly, but not fast enough, not far enough. because drag from the sun's outer atmosphere would pull Earth inward, slowly at first, then faster. The planet would spiral toward the sun, not over billions of years, but potentially much faster in this extreme scenario. And as it does, it would be torn apart. At this stage, Earth is no longer a living world. It is a dying object. Surface temperatures exceed thousands of degrees. The crust melts completely. The mantle churns. The core destabilizes. Tidal forces stretch the planet. Cracks form, then widen. Eventually, Earth may break apart. Fragments pulled into the sun. Consumed. Gone. In reality, this fate is billions of years away. The sun is about halfway through its life. It has around 5 billion years before becoming a red giant. When it does, the process will be slow. Earth will have time, at least in cosmic terms, to change. Life will likely be gone long before the sun expands fully, but our scenario removes time from the equation. It compresses billions of years into a single moment, and that's what makes it catastrophic, because life depends on stability, on gradual change, on predictability. Remove that and survival becomes impossible. Could we survive? Underground, in space. On another planet, not in this scenario, there is no warning, no preparation, no evacuation. The scale of change is too large, too fast. Even if humanity had advanced technology, the suddenness of the event would make survival nearly impossible. Because this isn't just a disaster. It's a transformation of the entire solar system. The effects wouldn't stop at Earth. Mercury and Venus would be consumed almost instantly. Mars would heat up dramatically. The outer planets would feel the increased radiation. Their atmospheres would change. Icy moons would begin to melt. The entire solar system would shift into a new phase. A dying phase, because a red giant is not a stable endpoint. It is a transition toward collapse, toward a white dwarf, toward the final stages of stellar life. So what does this scenario really show us? It shows how fragile our existence is, how dependent we are on a single star, a star that seems constant, reliable, unchanging, but in reality it is temporary. Everything we know, every ocean, every mountain, every living thing exists because of a balance. A balance that can, in theory, be broken, not tomorrow, not suddenly, but inevitably. One day the sun will change. And when it does, Earth's story will end. But if our star is destined to destroy us, the real question becomes, where do we go before that day arrives, and what happens if we're not ready?